So now that you know how to work with expressions involving exponents, now we're going to look at what we call exponential functions, which basically just means we're looking at equations that involve exponents as opposed to expressions. So I want to remind you that so far this year we've had a huge focus on linear equations, things that we can write in the form y equals mx plus b. So notice that that means we have no exponents on our variables, there's no multiplying between variables, and our graph makes a straight line. So you might think here when I say no multiplying between variables, but what about m and x? Remember, m stands for some constant slope. And we could have a straight line with a positive slope, a straight line with a negative slope, a straight vertical line, or a straight horizontal line. Okay, so that's what we focused on so far. So now when we're moving into exponential functions, we're going to have a function in the form a times b to the x. The variable is in the exponent as opposed to the variable being next to our slope with an exponent of 1. B is greater than 0 and b cannot equal 1. Right? For now, we're not going to really worry about the specifics and the why behind that. So for right now, I'm just going to tell you, we will talk about it in class, but for right now, I just need you to know that b has to be greater than 0 and cannot equal 1. If you want to make a graph for an exponential function, you're going to use an XY table to help you do that. And I am going to give you some general shapes of an exponential function. We'll make an XY table to make our graph. So let's say, for example, we wanted to make the graph y equals 5 to the x. So I'm going to choose some values for x and see what it gives me for y. So let's say I choose -2, -1, 0, 1, and 2 to see what's going on with my graph. Well, if I choose x equals -2, y equals 5 to the -2, which we learned is 1 over 5 squared, or 1/25th, which is a very small decimal. When x equals -1, I get y equals 5 to the -1, which as we learned is 1 over 5 to the +1, or 1/5. Not quite as small of a decimal. If I have y equals, when x equals 0, I have y equals 5 to the 0, which we know is y equals 1, because anything raised to the 0 power is 1. If I let x equal 1, I have y equals 5 to the 1, which is just 5. And if I have x equal 2, I get y equals 5 squared, which we know is 25. So if I go to actually graph this, notice I don't have any negative y values, so I'm not going to put negative y values for my axis here. I am going to go ahead and approximate my decimals because my fractions, because I sometimes think that graphing is easier with decimals than fractions. So that equals 0.04, and this equals 0.2. So when x is -2, y is 0.04, which is going to be very, very close to the y-axis. It shouldn't be quite on the y-axis. Let me try to make that a little bit better. And then when it's -1, it's still really close, but not quite as close. When it is 0, it's 1. When it is 1, it's 5. And when it's 2, it's 25. So probably like way up here. So notice my graph looks something like this. And what you're going to see is this is called an exponential growth function because my base that is being raised to the exponent is greater than 1. So notice that also, if I told you the form was a times b to the x, my a in front is 1. If there is no a written, it's 1 because 1 times 5 to the x is just 5 to the x. So let me show you what these functions are going to look like. So we're going to have basically two types of exponential functions we're looking at. And I'm sorry because I do realize that's spelled wrong. We're either going to have growth or decay. All exponential growth functions are going to look like the one we just looked at. They are going to have this general shape here, where they start out really slow and really close to the y-axis, and then they grow very rapidly. Decay is going to be kind of just the opposite. They're going to start out really big, and they're going to shrink really rapidly and get really, really close to 0. We're never actually going to touch 0. We call that an asymptote. Okay. So just some more characteristics of a growth function. A growth function, so like I said, it has that general form, y equals a times b to the x. B has to be greater than 1, so my base is bigger than 1. A, this is going to help us when we are working with story problems and creating our own equations. A is going to always be our starting amount. B is going to be what we call our growth factor. The way we find our growth factor is we take 100% plus whatever our percent increase is, and then we change that to a decimal. Our decay function is going to have that same general form, but now my base is going to be between 0 and 1. Fraction, decimal, however it's written, it's going to be between 0 and 1. A will still be my starting amount, but now because B is between 0 and 1, it's actually my decay factor, so I'm going to take 100% minus the decrease, and then I'm going to change that to a decimal. Remember that to change to a decimal, you move your decimal 2 places to the left. Okay. And I think I'm going to stop the video here. I was originally going to do just one video on exponential functions, but I think I'm going to have this one, and then I think I'm going to do the rest of the notes on a second video. So this will be your introduction to exponential functions, and the next video will be all examples. So from here you can now watch the next one. Keep those story problems. It'll be the kind of the same notes handout. If you did not print the handout out for exponential functions, I would strongly suggest you print out the notes template for this one, because the next video will be all story problem examples. So it'll be very helpful to have that so you don't have to write them all down.